presentation.
How do I navigate here? Okay. Hello, everyone. My name is Leonardo, and I'm going to present this improving CPU isolation with per CPU spinlocks. I give some performance numbers here. My name is Leonardo. I work at Red Hat, trying to work more on real-time stuff. You can find me with this handle, LeoBraz, in those networks. Well, when we are talking about real time, what we want is to run these time-sensitive tasks without interruption. One of the ways of achieving this is isolating the CPU, so no other things are running there. It helps in a lot of workloads. And one of the things that bother us in CPU isolation is that there are APIs. There are other CPUs scheduling work on the isolated CPUs, which should not be happening a lot, right? I'm focusing here in one use case. It's the per CPU caches. The whole idea is very efficient. The idea is that you have a single resource, a global resource, and you try to use it with multiple CPUs, and it's kind of hard because you have to compete. CPUs are competing for that resource. What we can do is to add these caches, and the whole idea is that you operate in local caches, which is quite efficient, and whenever you need anything else, you just lock the resource, and then it works. I mean, you reduce access to like global locks, and it makes things run faster. The thing is with this strategy is if you need to request things, let's say you are running out of memory, for example, and you need to request this resource memory from the other CPU caches, you need to do an API, meaning that you will stop the CPU for doing whatever it was doing, and you will require its CPU time. And it doesn't. Oh,
I took your presenter, so.
What?
Do you need a presenter right now?
Maybe I'm not being able to go to the next slide.
Okay, shoot. I didn't get to. You noticed.
Yeah.
There. Next slide.
Okay. This is how it mostly works. You have your hot path, which is the thing that you use most. You do the local lock, do the local work, local unlock it, and whenever eventually you need to access the caches from the remote CPUs, you will schedule work on that CPU. Could you please go to? Oh,
shit.
Yeah, not mine.
That was not supposed to happen.
I'm not ready.
Okay, let's take the presenter and put it back to you. Okay,
This-
so they changed the way things work.
This is a case of CPU isolation that wasn't respected.
What was the name of your presentation?
It's presentation.
Presentation.
What?
Presentation.
Oh, presentation. Okay.
Could you do the next slide, please?
I'm just going to make you presenter again.
Okay.
Do you have it now?
Let
Not
me.
perfect.
There's 2 LPC speakers. That's 3 LPC speakers. I don't know which one is us.
And for some reason, I can't go to the next.
Okay. Can you just take presenter from there? There's a little button. Because there's 3 LPC speakers.
Steve.
Oh, okay. Take presenter. Okay, great. No problem. The idea is that in this strategy, this local cache strategy, this thing here generates an API, and that's bad for CPU isolation. So what would be great if we could come with another efficient strategy that doesn't require the scheduled work on isolated CPUs. And the simplest and maybe dumbest way of doing that is using per CPU spinlocks. The whole idea is that differently in a different way, unless instead of using the local lock, you get the spin lock, and everything works the same. Whenever you need to do remote work on remote caches, on remote CPU's cache, you instead of scheduling work there, you just get the spin lock, the per CPU spin lock of that CPU, and do the work. And it's great because since this remote operations happen quite rarely, we can just don't worry about the contention. And that Mel Gorman did some work related to that in this commit that I pointed here. It's easier to show this that way. The whole idea is that you replace the spinlocks, the local locks with spinlocks, and then you, for each CPU, instead of like scheduling work, you just grab that CPU's spinlock. But whenever I say use a spinlock instead of a local lock, what everyone will ask is, well, but spinlocks are costly. We don't use them for a reason. And most of those costs come from contention, getting cache line exclusiveness, and memory barriers. Contention, as I explained before, is not a problem because these remote operations are quite rare. I run for hours and I could not get one case where someone tried to get the spinlock and was not able. Getting cache line exclusiveness is not very costly because you are like 99.999% of the time you are operating in your own cache line. You don't need to invalidate cache lines because you are mostly working on your cache line. And the last thing is memory barriers, which are not supposed to be that much expensive, but we are seeing this cost here. Those are for getting numbers here on how much a spinlock, local per CPU spinlock actually costs. I did these 2 tests. The idea is that I run 1 million times and get how many clock cycles that does it take. I run on x86 and ARM, get the number of cycles, and that's it. That's the test number 1, as I said. This test lock here is getting replaced. The reference is local lock, so every number will be like any more cycles. I do use the spinlock, inlined spinlock, and this textbook spinlock, which uses exchange instead of compare exchange, just to be sure to fetch the idea of how much we are expending more needing to do a full CAS operation instead of a blind CAS. The test 1 results is that a normal spinlock on x86 took 35 clock cycles extra, but when you go to inlined spinlocks, it goes down more than half. And this textbook example of spinlock takes a little less cycles in general terms. You have this K-malloc test, the same idea, but I created a C group with memory limitations and just did a lot of K-malloc. The locks here were changed in the memcg code. So the idea is that I'm testing on a real example here. And this is how much extra it costs for HK-malloc. On x86, it cost us 90 extra clock cycles. But if you inline this spinlock, it takes like 4 extra cycles for a full K-malloc. On ARM, it costs a little more, but anyway, the textbook example of spinlock here, it becomes very expensive. That may be the reason why we had opted up for compare exchange. Just a few numbers. Just commenting on like inlining the spinlocks is a good way of saving time. I mean, inlining it's enough for getting more than half of the cost of the spinlock. In this example here, it takes even more, like a lot. So maybe spinlocks, local spinlocks are not that costly, and we can like afford to replace the local locks in this case. The whole idea I already concluded, but there is a question. Why? Well, preempt-RT already turns local locks into spinlocks, which is good because means that someone already is have a success case on that. But there is a solution that we can just afford to, because on preempt-RT enabled, it costs mostly nothing. And there is this question, can we just improve CPU isolation on this scenario where preempt RT needs to be enabled for this improvement to happen? And if that's the case, why haven't we done that before? I mean, we have in preempt RT enable, we have always to pick a spin lock. Why are we scheduling work on that CPU and not just like grabbing the spin lock instead? And here I propose, I sent this patch before, I propose that the name is bogus. I just could not think on a good name for that. But the whole idea is that you can get, if you can get the other CPU's local lock, in this case of a spin lock, we can create new functions. And instead of like scheduling work on, we can use this helpers, local schedule work on, and instead of like really scheduling, we just grab the spin lock and do the work. The idea of implementing this is basically that you have your function that will not be run remotely. You use just the local lock, and if the test can be run remotely, meaning remotely not in the same CPU, you can just put the CPU number here. It will do the work and just get out. The idea is that this local lock and here will grab the local lock of the other CPU, which in this case would be a spin lock. And when you will require some remote work, you use this local queue work on, which here I explained that when preempt RT is enabled, it just grabs the remote spin lock, which is the local lock, and do the required work. And that's it. I suppose you can have any questions.
Just real quick, you said convert local locks into spin locks. You mean convert spin locks into local locks?
Yes, the idea is convert local locks.
Yeah, because some
Sorry,
of your
I'm
slides
kinda
kept saying converting local locks into spin locks. I'm like, I think you meant the other way around. I just want to clarify that.
Yeah, the idea is to convert local locks into spin locks. That's correct.
Okay, two.
The local locks came from RT, and they mostly come from the reason that we try to replace the preempt disable sections. That's why they became preempt disable non-RT. We used to have the local end thingy, but to keep the code the same for RT and non-RT, we got rid of it and had the schedule work thing just to have the same convention on non-RT. And yeah, that's mostly it.
What was the overhead?
Come again?
Did you test overhead of the So repeat for that, the overhead.
The overhead.
Overhead of like RT, this implementation in RT, we have overhead.
What overhead?
Yeah. Okay. Yeah. The implementation of when you did like what RT does with like how you did all this, and I guess you kind of said it too. There was really no measurable was there overhead? So basically, if you implemented this without all of RT, did the kernel notice it?
There's mostly no overhead because those logs mostly are never hit.
Right.
The origin use case is preempt disable, and most of the folks that care about it run it with preempt server, with preempt disable is completely gone. So
but I guess it'd be, have you done more benchmarks on this to see how this impacts like normal workloads or various workloads?
Yeah, I mean, that's true here is the example of a real workload. I mean, sorry. Yeah, I replaced the local lock with spin locks for.
And you replaced the spin locks with local locks.
Yes, no, local locks for spin locks.
Wait.
Yeah, I'm trying to get rid of the local locks on these.
So they are local locks here. Then you're trying to remove them with a spin lock.
Yes,
that's correct. So they are doing that.
Yeah.
Okay.
And I replaced the whole strategy here. So I took the idea of scheduling work on and just grab the remote spin lock and do this stuff. And those are the numbers that the overhead that I found. Does that answer?
Doesn't work.
Hi, I'm curious. I think there's the premise here that every one of these isolated CPUs actually needs to have this cache data that you're trying to protect. So I don't know the code. Can you tell us, did you have a look at the users and see, do the isolated CPUs actually need to maintain this cache data where you're trying to avoid the schedule work?
On a previous suggestion that I had on a previous patch, the solution was that people said just, well, in this memcg thing, it's easier just not to have the cache, but the cache was there for a reason. I mean, it brings more performance because you don't have to keep operating on the local, in the global spinlock, for example, for getting more memory. So yeah, it can be done, but it impacts performance. I'm trying to get with a solution that does not, or impacts as little as possible.
Thank you.
Yuri, and then Wayman. We have 2 minutes. Yeah.
In the case, you saw that inline spinlock has a pretty good performance benefit, but the fact that the inlining of spinlock code is controlled by some configure variable, and by default they are off.
Yeah.
So if you want to use it, the reason why they are off is because we don't want to increase the size of the text, and also the function size will get increased if they use spinlock and spinlock. So do you think that it will be useful to have a variant of spinlock that explicitly inline it, so that it can be used in the case of the local lock thing?
Sorry, could you repeat the question?
My question is, do you need a special variant of spinlock and spinlock that are explicitly inlined to make sure that you can get the benefit without affecting the other spinlock code?
Yeah, what I did was using the raw spinlock. If I recall correctly, that was the raw spinlock. The idea is that it's already inlined. There is, as you said, if you just do the spinlock, it won't be inlined. But I went down in the chain there and replaced the spinlock type for a raw spinlock type. And on both systems, it inlined the spinlock for that code specifically. I mean, I'm not inlining everything in the kernel just for this those 3 implementations that use it.
Okay, yeah, what spinlock is inlined? Yeah.
I think we can take it offline, but I was wondering about the actual, let's say, benchmark that you actually run when you, because you said the remote operations are not that frequent, but like we have particular situation where we actually see lots of them. So I was just wondering if you can provide more information about the actual workload that you run.
The workload that I run.
Yeah, to actually be able to say, I don't see many of the remote operations.
So this is time.
Yeah, we can take it offline.
Sure.
We have a chat online. Please log in and actually answer. Like, you actually can talk
Sure.
in chat.
I'll do that.
You guys work for the same company.
Yeah,
You can chat.
that is why I said we can. Yeah.
Thank you, everyone.
This is a